Okay, it was painful, but I did prove in a previous video that for a Gaussian distribution, the variance is equal to the square root of the standard deviation. And this is true as long as we have a Gaussian distribution, which is reasonable to assume for a randomly distributed data, because that's what the Gaussian is that it's a random coin toss taken to infinity. Now, practically, this is an easier number to calculate than this. This we would have to figure out through model fitting. So what we do is we make the false equivalency here. But the thing is, this isn't really correct. It works out that way for Gaussians, and we can do it. And this is practically what happens in Excel, is that it calculates the variance and just takes the square root of it. Now, standard deviation, we do need to qualify, though. There are two types of standard deviations. So there's a standard deviation by taking the square root minus xi squared all over n, and then the standard deviation taken by taking the square root sigma x minus xi squared all over n minus 1. So why is there a difference? Well, the n minus 1 should be kind of tracing it back to the average. So this is true if and only if we're looking with the complete data set. If we don't have a complete data set, we're simply sampling, we actually go to S. So S is made from the data that's within X, the total data set, but it's only a subset. It doesn't contain all the data points. So we lose that n minus 1 there to reflect the degrees of freedom, that we actually lost the degree of freedom when we went to go calculate the average, and we need to kind of pull that back out. But in Excel, this is stdev.p, this is stdev.s. And we need to be careful here. If we're not truly measuring a true full population, we do need to put this s in here. Now, as n trails off to infinity, meaning that we get larger and larger data sets, these two numbers do actually in fact converge. And that which should make sense as we start getting closer and closer where that xi equals complete set, then yes, we expect the two numbers to converge. But do be careful with that. There's a standard deviation for a population and a standard deviation for a sample set.